All right, so today we're going to be talking about objective 2.5, which is to use a quadratic formula to solve equations. So here is our quadratic formula. It tells us that if we have something, a quadratic in standard form, in the form ax squared plus bx plus c, then if you want to solve for x, you can use this formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So our first one is 10x squared, we're solving this equation, equals negative 11x plus 8. So what we need to do first is we need to get everything on one side so we can figure out what a, b, and c are. So I'm going to add 11x to the other side, subtract 8 so that everything is all on one side. So when I do that, I get 10x squared plus 11x minus 8 equals 0. All right, and now I'm able to identify that a is equal to 10, b is equal to 11, and c is equal to negative 8. So from here, I can go ahead and plug into my formula. So I see that we have negative b, and I know my b is 11, so I have negative 11 plus or minus the square root of b squared, so that is 11 squared, minus 4ac. So my a is 10, so minus 4 times 10 times my c, which is negative 8, all over 2 times a, which again was 10. Okay, so now when I start to solve this big equation, what I'm always going to recommend that we do is we're going to solve what's under the square root. So under the square root here, we see 11 squared minus 4 times 10 times negative 8. And when I plug that in to a calculator, I get that that value right there is 441. So I'm going to rewrite my equation, and I'm going to put x is equal to negative 11 plus or minus the square root of 441 over 2 times 10, which is 20. Okay, and so this is 441. It's kind of hard to see. So what I need to do now is I'm going to see if this is a perfect square. And this is a perfect square. The square root of 441 is 21. So I'm going to write x is equal to negative 11 plus or minus 21, all divided by 20. So what this does is this gives me two answers. So one of my answers is negative 11 plus 21 divided by 20. And then my other answer is negative 11 minus 21 divided by 20. So it's really important that you remember order of operations here. So plug it into the calculator either by making a fraction or by putting this top part in parentheses. So negative 11 plus 21 is going to give us 10 over 20, which is going to give us a half. And then our second answer is going to be negative 11 minus 21, which gives us negative 32 over 20, which the fraction reduces to negative 8 over 5. So my two answers are going to be x is equal to a half and negative 8 over 5. So here are my two answers. Meaning if I graphed this quadratic right here, it's going to cross the x-axis at 1/2 and negative 8/5. All right, so let's take a second to do our next one. This one is nice. It's already in standard form for us, so we're able to quickly identify that a is the coefficient in front of x squared, which there's an imaginary 1 there. B is 12, and then c is 1. So if we want to go ahead and plug into our formula, we know we're going to have negative whatever b is, so negative times b, which is 12, and then plus or minus the square root of b squared, so 12 squared, minus 4 times whatever a is, which is 1, times whatever c is, which was also 1, all over 2 times a, which is 1. Okay, so again, I am always going to start by solving whatever is under the square root. So we have 12 squared, which is 144, minus 4 times 1 times 1, which is 4. So 144 minus 4 gives us 140. So we have negative 12 plus or minus the square root of 140, all divided by 2. So the square root of 140 is not a perfect square, so we're going to keep it just like this. And I should say that that is equal to x. So again, this is two answers. Negative 12 plus the square root of 140 over 2. My other answer is negative 12 minus the square root of 140 divided by 2. Also, it is very important. I may notice that 12, 140, and 2 are all divisible by 2, but I cannot reduce this into 6, reduce this as 1, and then cut this in half as 70. So we cannot do that. So we're going to keep it just like this. All right. And then lastly, we have x squared plus 10x plus 29 is equal to 0. All right, so again, this one is also already in standard form. So I can identify that, ooh, I should have used purple. I can identify that my a is going to be 1 because that's what's in front of my x squared term. My b is going to be 10. And my c is going to be 29. We're going to plug right into our formula. Then we have negative times whatever b is, which is 10, minus, or plus or minus, the square root of b squared, so 10 squared, minus 4, times a, which is 1, times c, which is 29. And the entire thing is over 2 times a, which is 1. Again, always starting by doing what's under my square root. So we're going to have negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 29, which ends up being negative 16. We're going to divide that by 2. All right? And so we should notice right here, this is an imaginary number because we have the square root of a negative. So if I wanted to kind of take this one step further, I'm going to keep this negative 10 here, plus or minus, and the square root of 16 is 4, and then the square root of that negative sign, or that negative 1 that's in there, is going to be I. All of that is over 2. So this one, which is a little bit different from this one, we do have, so you can keep it just like that. Like there is your answer. We know x equals that. Or we could say that we're going to do that we can cancel out a factor because this has a 10, a 4, and a 2. So what we could do is we could make this into a 5. We could make this into a 2. We could make this into a 1 because the 2 goes into all of those. Again, that is not the same as this one because there's no coefficient in front of the square root here. All right? And so we're going to get that x is equal to 5 plus or minus 2i. So you could have kept it as negative 10 plus or minus 4i all over 2, but just wanted you to know that this is also equivalent. Thank you.